obviously a real pleasure to be talking to you guys today. And what I want to do is start by giving you a little challenge, a cognitive challenge that we have tested chimpanzees with. So if you guys can bear with me, my first goal in my talk is to help you understand what cognition is. Because I think a lot of people know the word, but if somebody really pushed you and said, what is it? You'd kind of be like, it has to do with intelligence and I don't know. So even I do that. I want to help you be able to answer that question and feel more comfortable so that if somebody asks you what is cognition, you'll actually be able to say, here is what it is. But first, I want to demonstrate to you that you are potentially cognitive.
Awake would be
does anybody remember this morning? Okay, good. Okay, so the key thing of me asking you that is that you didn't move, you didn't behave, but I think many of you, if you didn't think about this morning, you thought about me asking you that question. There's an internal process going on that is private, potentially, and it didn't require any behavior. That's the key thing. Cognition is not synonymous with behavior, okay? So let me just see how you do here. There is a chimpanzee named Yo-Yo, and actually I'm gonna see if this laser pointer works because that's gonna help me a little bit. Let's see. This is not part of the test. I'm really being tested here to see if I can get this thing going, but that's all right. Okay, so hopefully you can see where the little hand is. There is a PVC, thank you very much. There's a PVC pipe there. At the bottom of that pipe is a peanut, which is essentially like winning, Westminster for a chimpanzee. And Yo-Yo is an orphan of the bushmeat trade. She lives in Uganda. You can go visit her at Ngamba Island if you fly to Entebbe, beautiful city, and you take a little boat ride out to Ngamba Island. You can go see her. We study her cognition. We've been working with her for years, and the other chimpanzees she lives with. And we gave her this game. And here's the key thing: she's never seen this problem before, ever. And the problem is that she would like to get the peanut out of the tube, but the tube is attached to the bars, and you all know that chimpanzees are famously clever with tools, but we've taken all the tools away that she might use to solve this problem. And of course, we're nice, even though we're mean, we took the tools away. Obviously, everything she would need to be happy in a room and be taken care of in a captive setting is there. So here's your challenge. She's never seen this before. She's just now encountered the problem right now in the video. And within a few seconds, she knows the solution. So your challenge is, don't yell it out, solve this problem before she does. Okay, go ahead and roll the film. How would you do it? How would you get the peanut out of the tube? Fingers aren't long enough, no tools in the room. She's already got the solution. She's coming back with the solution. Hopefully you've beaten her and you know what the solution is. There's actually two solutions. So this is a great demonstration of cognition because her cognitive abilities allowed her to flexibly solve a problem she'd never seen before. She had to make an inference about how she could use water in a new way that she'd never used before. But because she understood the properties of water and she understood that peanuts can float, she was able to then make an inference. Now, does anybody want to raise their hand and tell me the second solution? There is one more solution. Okay, it's a very male solution.
Break it. Pull the tube.
I heard break it. Anybody else?
Pull the tube off the bar.
Pee in it, yes! That's exactly right. So, some of the male chimpanzees peed in the tube and got the peanuts. That's right. Anyway, no females did that. Not one. Okay, so this is a great example of what cognition is. Okay, so... Alright, so what I want to do is introduce to you the cognitive approach. And I think that the thing that I need to help you with, if you haven't already arrived here, is that the idea that there's a continuum between sponges and humans and that intelligence or cognition is something you just have more or less of. It's like a cup, it's either full or empty. That is factually incorrect. And I think that for a very long time, that's how people think about it. In fact, after I give talks, generally people will come up to me, even after I give the talk I'm about to give, and they'll say, yes, my dog is very smart. And I'm like, okay, so I feel like a failure. So you guys are going to do better than that, okay? I know it. All right, so the idea of the cognitive approach is there are actually lots of different intelligence. There are lots of different types of intelligence, and they're designed to solve different problems. And the key thing is they're not always related or correlated with each other. You can have an individual in this room who is very mathematically inclined and is a horrible communicator. You can have somebody who is a wonderful communicator and is a dismal mathematician. It is exactly the same idea that we have with people, is there are different types of intelligence and that they can vary independently. So you can have an individual looks like this, where the size of the circle is sort of how skilled or flexible they are with a different type of problem or with a cognitive skill. Okay, so the challenge is not, is an individual or a species smart or not? The challenge is, what is their cognitive profile? What is it that allows them to survive and reproduce and be successful in a flexible way? How many of you have echolocation? Okay, so bats don't think you're very smart then. Okay, so that's how we think about cognition, is there's different types of abilities that have evolved to solve different types of problems. We don't need echolocation in our evolutionary history, so we don't use it, and we're not very good at it. Okay, so what that cognitive approach does is it allows us to look at individuals or species and lay out their cognitive profile. So in this case, you have two individuals or two species that differ in their empathy, that differ in their inhibitory control, that differ in their memory, their social learning, it's about the same, and slight difference in their navigational abilities, okay? So that's what we do, is we go, and these are just, and there's an etc. there. It's as challenging as this. As I tell you there are different types of intelligence, I couldn't tell you how many there are. I couldn't even tell you that for sure that we know really how to measure them. There are some things that we're really good at measuring, but there's lots of other things that we're not as sure about. So, I hope what I've helped communicate is that cognition is an internal process. It's something going on inside your mind. It's not behavior. Now, in animals, we measure problem-solving ability, and we make inferences about what's going on in the minds of animals by measuring and observing their behavior. But that doesn't mean that I'm actually totally uninterested in behavior. What I'm interested in is the mind of the animal and what's going on inside that I can't see. The only way that I can measure it is by looking at their behavior, okay? So, and the thing that we get most excited about, it's not the only thing we study, but the thing we get most excited about is the example of Yo-Yo spontaneously solving a problem she's never seen before and potentially using inferential reasoning. She had to make an inference and solve a problem, probably imagining what the solution is in her head before she even tried to solve it, okay? So this isn't training, this isn't repetition, this isn't something that she had to practice. She just figured it out. Okay, and then there are many different types of intelligence, and they often vary independently, and that could be across species, that could be across different individuals. So, in sum, I hope what you will take away is that cognition is the mind, and it's the mind flexibly solving problems. That's what cognition is. So, I hope that's really exciting, and the reason that I pointed and I looked up at the ceiling is that was just another demonstration of you having a mind. And your mind is actually fascinatingly complicated because many of you, when I pointed and looked up, you either looked up to where I looked or you said yourself, is this guy crazy? What does he see? What is he doing? What is his intention? You were asking yourself all sorts of questions about what was going on in my mind. And you couldn't help it. And it was all internal and you didn't behave. Okay, that's cognition. You can't always see it, but hopefully we can design games to play to measure the behavior so that then we can reveal not just what humans do, but also non-humans. I don't know, you guys feel any more confident you could explain it to somebody?
Yes.
Okay,
yeah.
You're very polite. All right, so at Duke, at my research group, we're really interested in trying to figure out what is it that makes us human, and our second question is, how do we get that way? And our underlying assumption is, if you want to know what it is to be human, you first have to know what it is to be not human. How do you, as a philosopher, or a philosopher of the mind, or a cognitive scientist, or a neurobiologist, have some plausible hypothesis about what it is to be human if you don't know anything about non-humans? If you have a hypothesis that, for instance, humans are the only species that use tools, or that are capable of inferential reasoning, or communicate in a flexible way, which these are all hypotheses that have been destroyed by studying non-humans, you're going to be wrong. So we have to study non-humans in order to understand what it is to be human, and to understand our evolutionary history and how we became the way that we are. So that's why I'm an evolutionary anthropologist. I'm very lucky. I have access to 2 sanctuaries in Africa where we study apes. We study bonobos and chimpanzees. If you haven't heard of a bonobo, you want to know about them. They're wonderful. They're basically the dog of our ape family. And in all the good ways, the things we love about dogs, bonobos are very similar in many ways. And then we study lemurs at the Duke Lemur Center, but of course we run and we work hard at the Duke CanineCognition Center to study people's pet dogs. So obviously I'm here to talk to you about the Duke CanineCognition Center, and we're very, very lucky because we have about 1,500 people locally in the Durham, Chapel Hill, Raleigh area, the Triangle, who volunteer to bring their pet dogs in and play games so we can see how they think and how they sometimes don't think. It's been a real delight to meet all these people and to have them bring their dogs in and learn how their dogs think, and have them contribute to science. And it's wonderful in a way because I was educated in the traditional, conventional way that you do science, which is that you have animals in cages and you study whatever you want to study in a very controlled setting, and you own the animals. But given what I just told you cognition is, I'm trying to understand I'm trying to push the limits of the animal mind. I want to know the most sophisticated things that animals can potentially do. So I kind of want to study the most sophisticated animals that are out there, and they're in your homes, and not in cages. So it's wonderful because it means that animals aren't in a laboratory setting, and people actually get to participate in science, and we have a lot of fun doing it. So this is an example, very simple games. I think one of the most important things to understand is that theoretically and methodologically, what's happened in the last 10 to 15 years is that people are studying dogs using theory and method from developmental psychology, from studying human infants. And that's what's the big change, I think. If you were just going to ask me in one sentence, tell me why is it that all of a sudden there's all this stuff about dog cognition? It's because we're studying dogs using the same theories and methods used to study human infants. And that's been what the big change is. So we've used very simple nonverbal measures, the same type of thing we'd use with human children, because they're nonverbal, if you have ever met any that are not yet linguistic. So there's a lot of conversation between developmental psychologists and people working with animals, and sharing of methods and ideas and testing hypotheses. So what's happened in the last 10 to 15 years is there's really been a revolution. It's gone from, there's no way that anybody who's interested in what I just told you I'm interested in terms of our questions, that you would study dogs. Dogs are totally irrelevant. Why would you study dogs? They're totally unremarkable. There's nothing interesting about them at all if you're going to push the envelope of the dog mind. And it's changed to, you have to study dogs. They're actually the most important and interesting species you could study if you're interested in questions even about human evolution. So people are asking questions like, do dogs imitate? Are they capable of intentional deception? Do they know what you can and can't see? Do they know what you do or do not know? Do they understand symbols like children? Do they navigate? Do they use shortcuts? And of course, do dog breeds differ, which is at the heart of what you guys love and get excited about. And we're trying to use the information in an applied setting as well. We've done enough research where we can start to now apply what we've learned, and I hope that 2/3 of my talk is going to be about that. So my wife convinced me to write a book about basically this revolution that's occurred, that because dogs have become remarkable, science has woken up, that this is the most important species that we could potentially be studying if we're interested in the animal mind, and there's so many reasons why. We tell the story in the book of how this all occurred, but I'll tell you a short version now. But the thing to understand about the book is what makes it different from other dog books is it's about the peer-reviewed scientific literature. And for me, what I'm most proud of and what annoys my wife the most, my co-author, is the last 70 pages that no one will ever read. And the last 70 pages are the endnotes. And there are 700 papers cited there because we did a comprehensive literature review. And every word in that book is us doing our very, very best to represent the scientific literature. And everything we say in there, there's an endnote that you can go argue with us and tell us we're stupid and wrong. And that's fine, because that's science. It's a conversation. I don't know everything, and that's the fun thing. I'm happy to be wrong if you can demonstrate to me that I was getting it messed up. So, so that's why that's there, is for you to be able to go in and critique it and to push the science forward if you'd like. So, how I started studying dog psychology was a total accident. I went to Emory University. I was interested in developmental psychology and also in human evolution. I was working with chimpanzees with my advisor, Mike Tomasello, who is a very famous linguist and also developmental psychologist. He actually had never owned a dog. And we were doing studies on chimpanzees where, not dissimilar from where I looked up and you were making inferences about what I was thinking, we were trying to see, do chimpanzees do the same thing? And we were trying to communicate to them where food was using pointing gestures and looking to where food is that they would like to find but they don't know where it is. Because the idea was, if they can do the similar thing you did, that suggests that we are not alone in the ability to think about the thoughts of others. I think the important thing to communicate here is no one is arguing in cognitive science about do animals think. That's not an argument, whether it is in the media, which I see articles all the time. Do animals think? And I was like, oh, of course they think. The question is, do animals think about others thinking? And so that was the question we've been trying to answer. It's a tough question, because obviously it's an internal process. And so we were finding something very fascinating with chimpanzees, is they were really struggling to find hidden food using pointing gestures and using gaze direction. And so my advisor said, this is really amazing because human kids scaffold almost everything that comes later on this early emerging skill to understand others' point and to start producing pointing gestures and to understand gaze. And it's an early indicator of this ability to think about the thoughts of others. And that all cultural cognition, including language, is built on this. And in developmental psychology, people have seen that if these skills don't develop, kids have developmental delays. And they really struggle to, for instance, acquire language and participate and acquire cultural knowledge. So when the chimpanzees, and subsequently bonobos and other apes, struggled on these tests, Mike's conclusion was, well, this is unique to humans, and this is something that's evolved uniquely in our species and is a crucial thing that happened during human evolution that allows us to be so different than other species and a crucial part of human evolution. And so being a stupid 19-year-old who didn't know that you weren't supposed to question your advisor, and having been raised in Atlanta, Georgia by a dog named Oreo, who loved to play fetch with multiple tennis balls and would lose them constantly and then bark at you until you pointed at where you threw them. I was like, well, I think my dog does that. And so, I can say that, I'm from Atlanta. All right. So I probably did say it a little bit like that. And so, you know, Mike said, that's ridiculous. You know, everybody thinks their dog does calculus. Blah, 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 you're being anthropomorphic, blah, blah, blah. I said, no. You know, I told the story of Oreo, and you all are familiar. And with, you know, fetch-crazy OCD dogs. And so he said, well, look, you seem really serious. You seem convinced by this. Let's go do an experiment. And this is the point right here to talk about what science is and what makes it different from other things. Is that Mike Tomasello, an incredibly famous linguist, developmental psychologist, who, you know, traveled all over the world and people bow at his feet, was happy to be wrong and proved wrong by a 19-year-old. That's a great scientist. And that's what science is. It's not about being be right. It's about being willing to accept new information that could potentially help and change and reveal truth that you weren't aware of. So, you know, I try to be that good. I can't say that I am. I argue with my students all the time, and I try to remember, oh yeah, right, this is how I got started. So we did a whole bunch of studies where basically we took Oreo and we did the simple test. We hid food in one of two places, and if you're a dog owner, you're like, really? This is news? Well, to science it was. It's like, wow, this is amazing. Dogs follow point, and they go to where you look, and they even pay attention to where other dogs look, and they use arbitrary novel cues that they've never seen before. You can control for motion. We did 1 million controls. It's not all the little low-level stuff like, oh, they see you wiggle and they go in that direction or anything like this. No, it was very sophisticated. And it looked like what young human children were doing. Now this is the part where you start to not believe me for a moment, okay? Because we also did an olfactory control. And you're not gonna believe me, okay? And I still love you and it's okay. But we've done, and we is a whole group of scientists, not just me, have done dozens of studies on this because we didn't believe it either at first. But I can tell you that in this context, if you hide food in one of two places and then you try to let your dog, on the first try, on their first choice, guess where the food is, they completely are a chance. They're guessing. So if you give them a visual cue, so you point, they're great. 75–80% of the time they go to where the food is. So that's how we knew that they were using visual information and not olfactory information, is that we took away the visual information and they can't find the food. Now, they got very quiet because you're all very skeptical. And that's fine. I'm going to tell you how you can, with your own dog, test this yourself later. And then you can write me in and say, haha, you're wrong. And that's fine. But right now, there's really overwhelming evidence that in this context, dogs cannot use their sniffers to find food. Okay, so we even went as far to directly compare chimpanzees and dogs. With these games, and if you could just roll the chimpanzee video, there's a grape. I'm going to hide it in one of two places. It's not complicated. This is a cue that Fifi, the chimpanzee in Germany, has never seen before. I'm going to just put a block on top of it, of where the food is. You know where it is, and you see, oh, bummer. Just goes off scratching your head. Okay, and then if you're a chimpanzee lover like me, roll the second video. Even though they're as smart as Yo-Yo, here is this goofy German dog. I don't know the breed, maybe somebody does. And never seen this before in this context. And okay, here we go. Oh, okay, yeah, it's just over there, no problem. Why don't you just hand it to me? Duh. Okay, so then, we did a direct statistical comparison. We've subsequently done this a couple other times, and you find over and over and over again that dogs outperform, in this context, chimpanzees, our closest relative. So that's really fun. So that got a lot of people's attention. And I started to wonder about the origin of these abilities, and so that I can get to the second part of my talk, I cut it short and tell you that we did a lot of research, and the punchline is, it's domestication. It's selection against aggression. It's not that dogs have to slowly learn to do these abilities. They come born prepared to learn these things very quickly. It's not, I'm not standing up here being a genetic determinist. I'm not saying that they don't need some experience to acquire these abilities, but what I'm telling you is that a 6 to 9 week old puppy can perform as well as an adult dog, and that wolves look like chimpanzees, and that is crazy early for something to emerge and for them to show that much flexibility. So sure, okay, yeah, maybe 13 weeks, that's a few weeks of life, maybe they learn something, but what, 13 weeks? They can do that already? So it's something that emerges very early, and it seems that it's a product of domestication. And we even went and looked at the experimentally domesticated foxes in Siberia to test that idea. And there's a New Guinea singing dog there for any singer people, if there's anybody here who loves singers. So we wrote a paper, which, you know, obviously this, you can imagine with this title, got a lot of attention. And we just reviewed the literature and said, look, it looks in many ways like dogs and their social skills, and the exact social skills that developmental psychologists have been so excited about explaining human evolution have convergently appeared in dogs as a result of domestication. And so, remember, I told you my two questions are what makes us human, but then how did we get that way? So dogs have become really fascinating to scientists because they're telling us how cognition evolves. How could you become more human-like from an ape-like common ancestor we shared with bonobos and chimpanzees. Well, another species that seems to have changed in a similar way to us are dogs. And so by studying how dogs became dogs, we can make inferences about how humans became humans. So that's why I'm in an evolutionary anthropology department. Okay, so we review all this. Please have fun reading the book. That, you know, okay, I know this math problem, so now I can do this new math problem. No, it was through imitation. And what Philip could do is you could show Philip a novel action that he'd never seen before, and then he could mimic that action with his body plan without any practice whatsoever. And the new finding is that you can, that they have a whole group of dogs who can do this, and you can show them an action they've never seen, like do a pirouette, and then touch this over here, and they've never seen this before, and you show them an action, you take them behind a barrier, so they forget, you know, you play fetch with them for a couple minutes, you bring them back, and they go do it. And they remembered what they had seen, and they go do as you do. So I was like, really? Come on, that can't be true. But, you know, that's the fun thing about science. Now somebody will go try to replicate it, and, you know, given the robustness of the finding, I bet it does replicate. So I promised you that there's application to this stuff. It's not just, wow, dogs are smart. And I want to tell you the key thing is, I'm not trying to find out that dogs are little people. I'm not interested in that at all. I'm just trying to understand dogs for being dogs. And I want to understand not just what they can do flexibly and where they have unique and amazing abilities, which of course is fun to share with you, but I also want to know where they're a bit vapid and where they really struggle to solve problems, because that's going to help us in the real world. When you're being led around by a dog and you're blind, or you're looking for a bomb, you want to know the limitations of your helper so that you can be aware of that. So I just want you to know, I'm not trying to make dogs into little people. I just want to understand what they're capable of and what their strengths and weaknesses are. So on the applied side, I've been really lucky. I've worked with Dr. Evan McLean. He's a former graduate student of mine. Now he's the co-director of the Duke CanineCognition with me, deservedly so. He is the human, not the little bonobo, just to be clear. I imagine you'll be hearing from him in the future a lot. And you'll be hearing that name because he is really an up-and-coming star. And basically the idea is that just like in humans, we've worked very hard to figure out what to measure to capitalize on the cognitive strengths of people, to get them in the right jobs that they could do best at. Our goal is to sort of do the same thing with working dogs. Can we come up with ways to help measure these internal processes that then would help us place dogs in the right jobs that would help people and also help dogs? So we came up with a whole series of games. There's actually over 30 in what's called a cognitive test battery. And we've now administered these games to hundreds of dogs. We've been working with Canine Commands for Independence. We've been working with the Marines, testing dogs that had been deployed in Afghanistan, etc., to look at what are the traits, the cognitive traits that predict success in these programs. And I won't go through all the tests, but this is just to say there are lots of them. And our goal is to find games that not only measure internal states, cognitive abilities, but that actually predict performance in the real world. So here's an example where we're going to hide food in a tube, and you have to not bump into the tube, but actually take a detour and go around the edge of the cylinder and get the food, not bump into the front of the transparent cylinder. So the idea is you can see the food, but just because you can see it doesn't mean you can grab for it. You have to actually take a detour and reach in through the end of the cylinder. When you show people that, you're like, you gotta be kidding me. This is what you do for a living? Yep, that's what I do. I put food in Coke bottles and see if dogs can get it. It's a lot of fun. But the reason we do it is because it's nonverbal, it's very simple, it doesn't take any training, you can do it really fast, that means I can measure lots of dogs, and we think that it has a lot to do with, for instance, you're in Afghanistan looking for a bomb, and instead your bomb-detecting dog runs off and chases goats, because it has no inhibitory control. It sees the goats, but it can't remember or it can't control itself in a way that is productive. Another game would be, you have a problem, very easy. You put food in a box. You close the box. Now you can't open the box anymore. The dog can easily open the box and get the food, but then you make the task impossible. You close the box. You seal it so the dog can no longer open the box. And the simple question is, what does the dog do? There's no way the dog could get the food out of the box. So if you're a wolf, you will continually try to rip the shreds out of the box. But what we found with dogs is, and this is originally Adam McClosey's work, dogs very quickly, relative to wolves, actually within 30 or 40 seconds, will turn around and say, hey, you, human.
Yes, this is you.
You gave me a box and it's broken. So they use us as tools, but there's a lot of individual variability. So some dogs do that immediately, and then some dogs perform more like wolves, and will sit there and are incredibly determined to get at that biscuit and don't ask for any help. And so what does that have to do with the real world situation where you're searching for bombs or trying to help people as a service dog? So this is just a teaser. We actually have way more data, but this is preliminary data from CCI. This is some of the games that we played. And from a very small sample, we found that there were 3 games that were incredibly predictive of performance through service dog training. I can tell you that actually now that we have a larger sample, we have a bunch more that were very predictive of performance. And the idea is to identify dogs earlier, to be to have more measures to monitor and sort of check in on dogs as they're aging, etc., and make sure that they're able to do their dog really well. But here's a really fun one, since you guys love breeds. So this is a comparison of hundreds of service dogs and hundreds of, sorry, not hundreds, it's dozens, excuse me. Getting too excited over here. Dozens, we have that data, but this does not represent it. Dozens of military dogs and dozens of service dogs, and a comparison on these games. And what you're seeing, anything above that dotted line is where the 2 populations were different. But here's where it's super, super, super exciting. They are all Labrador Retrievers. All of them.
All labs.
They're all Labrador Retrievers. They're all the same breed. But one population of Labrador Retrievers is incredibly different cognitively than the other. And in about 10 different ways. So this is just a great example of what it is to develop a cognitive profile. Just because they look the same doesn't mean they are the same. So here's a great example. I'll just run you through some. This is some inhibitory games, and what you see in red is the service dogs, and in blue or green are the K2 military dogs, the Marine dogs. And this is an inhibitory control task. And they're very different. Another inhibitory control task where it's actually that cylinder task where you put the food in the cylinder. And what you see is the service dogs, what this data represents is the service dogs are incredibly inhibited and very good at the inhibitory control task. This is a pretty funny story. If you come to the CanineCognition Center, I can show you our skateboard helmets. Now, I walk in one day and I see on our purchase orders that my lab members have bought 4 skateboard helmets. And I'm like, why did you guys buy 4 skateboard helmets? And then they showed me the videos of the military dogs playing the inhibitory control game. Okay, you guys can buy more if you need to. So they literally run through the tube. The most uninhibited dogs you've ever seen. There obviously is some overlap, but there are places where these 2 dogs, if you showed me this data, I would tell you that these have to be different species based on the data. I've never seen species differences that are that big. These are huge differences. Okay, so then this is that help solicitation game we were talking about, and again, you see big differences between the 2 populations. If you're searching for bombs, actually you do not want help seekers. You do not want the dog that wants your help. And so, you know, we were able to document that they have some dogs they've been working with that are really help seekers. Now, the service dogs, it's actually potentially advantageous. We've also done traditional temperament testing, so behavioral measures, but we also looked at hormonal measures, cortisol in particular. We found huge behavioral differences in temperament. So basically, we find that the military dogs have a really big startle response. They respond they're very reactive. Again, these are all Labrador Retrievers. One population is very reactive, and the service dogs totally non-reactive, like literally don't even move like nothing's happened. even though it's crazy loud thunderstorm type sounds. But this is the really important part where I hammer home the message about internal processes. The behavior looks totally different. Does that mean that the internal process is different?
No.
Here's the cortisol data from the two populations. And so what you'd expect if they're different is that, first of all, those lines shouldn't overlap completely 100%. And what you're seeing is that over time, after being exposed to a stressor, they're all Labrador retrievers, their HPA axis is responding the exact same way. Both populations are very stressed if we use cortisol as an indicator of stress. And they recover probably in a similar way from the stressor. So if you were going to use the behavioral measure, you would conclude, oh, service dogs aren't stressed out at all. If you look at the cortisol, though, you realize actually they are really stressed out. And if you've measured their cognition and you know that they're incredibly inhibited, you understand it's not that they're not stressed out. These are incredibly inhibited dogs. They're controlling their response to something they're really stressed out about. So that's a cognitive approach. We can really see the mechanisms that are driving the behavior. So that's the difference between if you just studied the behavior versus you use the behavior to make inferences about internal processes and the cognitive abilities of these dogs. You can see much more with fine-grained resolution. And of course, if you're a service dog, you'd really like your human owners to know that actually, yeah, I'm pretty stressed out right now, even though I'm able to inhibit it. And that's going to help us, I think, in the future, identify dogs that can deal with these stresses and help us come up with strategies to help them. And help people understand that when they're working, they are potentially as stressed out as other dogs, even though they don't look stressed. So now, for the final part of my lecture, Sheila, where are you? Are you still here? How am I doing on time?
You've got about a little over 10 minutes.
Great. That's perfect. All right. So, welcome to CanineCognition. I want to tell you about what I think is super exciting, because the CanineCognition is great. We've made discoveries, we've done applied research, we've done basic research, we've gotten some people into vet school who are very sophisticated about understanding cognition, and you know, we have 1,500 people who participate. But the problem is, we have 1,500 people who participate. There are 100 million dog owners. I bet there are lots of other people who might be interested in learning about their dogs. The other thing is the 1,500 people are wonderful human beings, because here's why. They keep coming, they have not stopped coming, and every time after they leave and they've helped our undergraduates do their different projects and our graduate students and me, we tell them nothing. We say, thank you, you're a wonderful person, your dog did great. And they leave, and they're really happy. And then maybe 2 years later, we're like, hey, we have this publication that's really boring and you don't want to read, and thanks for helping us. And that's the CanineCognition Center. It's not very good from the perspective of the dog owner, although people keep coming. So I'm very thankful for that. But what we realized was, what if we could provide something that could allow everybody in the world, so I don't get the emails from the people anymore from California telling me they want to bring their dog to Duke, or from New York or wherever else. I have people from England who've written me. Please don't bring your dog. And so what if we could give everybody in the world the opportunity to potentially play these games? What if we could instantly, instead of our games at Duke that are designed to tell us about dogs as a species or a group of dogs, what if we could design things to tell us about individual dogs? And so that's what CanineCognition is. It's a celebration of individual dogs, and it gives everybody the ability to measure the cognitive profile of your dog. And to potentially contribute to the greater good of all dogs. Because we can ask questions that we can't ask at Duke. Now you guys, of course, want to know about breed differences in cognition. And we have a whole chapter in our book out there that is going to be horrendously disappointing for you, because science is pretty much silent on the topic. I know I would love to interview every single one of you and sit with you and talk to you about your different breeds and the types of behaviors they do, because I'm sitting in a room full of geniuses, experts who know more about animals than I do for sure. But what I can tell you is from a scientific perspective, if you wanted to go to the peer-reviewed literature, go to Google Scholar and look up breed differences, you're going to be really disappointed. There's nothing you know, that's particularly compelling. And I can tell you what the reason is. It's a math problem. There are over 100 breeds. for me to show a difference in one cognitive ability, I'm going to need 30 individuals per breed, and I'm going to need, at least, and maybe 30 puppies. And so you do the math, that's going to be a lot of dogs, and I'm going to spend the rest of my career doing one cognitive trait trying to find a breed difference. So it's impossible, and no scientists like myself or Adam McCloskey and others are going to attempt it. So we're not going to learn about breed differences from a scientific perspective, if you're interested in that. The only way we're going to do it is through citizen science and through crowd sourcing. And so that's what Cognition gives us the possibility to do, is if you communicate to people about Cognition through your breed groups, we can learn about the cognitive profiles of your breed groups. And obviously we're very happy to analyze data on specific breeds, to compare different breeds you're interested in comparing, and report those findings back to everybody, and make huge, important, interesting discoveries, like for instance, do Chihuahuas have better memory than Great Danes? I bet they do. Okay. So it's a science-based company. We have some of the best minds helping us put this together, so it's not just me. I have people giving me a hard time about how we can do it better. And everybody from Adam McCloskey to Julian Kaminsky. What we do is we give you the tools to measure your dog's memory, their reasoning abilities, so inferential reasoning, their communicative abilities, how cunning they are, and their empathy. Now the key thing about Cognition is I'll tell you this funny story. People, since I do what I do, people always want to tell me about their dogs and how smart they are, which is fine, I love the stories. But if you ask me the median story, what's the one that everybody always tells me? My dog is so smart. So, okay? And what people always say is, my dog can open a door. I'm not kidding, that's what people tell me. My dog can open a door. And so, it's not that that's a low bar that sort of makes me think, gosh, we can do better than this. It's that if I was impolite and I would say, well, when you think about how smart your dog is, have you ever thought about comparing it to other dogs? Because anytime you say something is better than something or something is different from something, that's a comparison. But I think basically people had an expectation that their dog was really, really horribly stupid, and when it opened the door, they were really impressed. But what Cognition is about is comparing your dog to all the data in our database at Cognition, and your data that you collect with your dog will automatically be analyzed and compared to every dog in our database and tell you what is your dog's cognitive profile compared to all the other dogs in our database. So when you measure these 5 different core competencies that make them great dogs. And the other key thing to say here is that, before I leave the slide, is a cognitive approach, remember, is not about more or less. It's not about is your dog smarter. It's about what's their cognitive profile. What are the skills they're using to be so successful? Okay, great. The Great Dane didn't have as good a memory as the Chihuahua. But guess what? The Great Dane is an incredible communicator. Or the Great Dane is incredibly empathic. Or the Great Dane is amazing at inferential reasoning games. What is the strength of your breed compared to other breeds? What is your dog's individual cognitive profile relative to other dogs? The fun thing is, you'll probably be wrong. Because I tested my own dog and was embarrassed to learn, and shocked, honestly, knowing him. Just to give you some background, his name is Tasmania. And he scored off the charts on the empathy games. I can assure you, I did not predict that. So, when you go to the website, unfortunately, I would love to take you right now to the website. I'll log in and I would brag on my dog and his cognitive profile. And I could show you his 15-page report that tells me everything about how he's similar and different to other dogs and how he compares to wolves and chimpanzees in his cognitive profile. But the internet apparently is not working in this room. So I will trust that you'll go to Cognition.com on your own. And actually, Tasmania's report is viewable there. But what you'll see once you log in, and actually 2 of the 5 dimensions are currently free, and you have a coupon in your conference bag. I just want to point out it's only good till the 31st. Sorry about that. So if you need to rush to your computers and log in and use your coupon. But it's also free to get started if you don't want to commit before you actually play some of these games. But what you'll do is you'll go, you log in, you make an account, and then there are videos that will walk you through how to play the games, and they're very professionally done. All these games were designed to be able to use either your iPad or your iPhone as your data collection device, or you can use your desktop if you don't like iPhones and iPads, or your smartphone, or whatever your equivalent device is. And you watch the video. These games are incredibly simple, and they're designed to be that way, but they're very powerful in measuring how your dog is solving problems. And every single one of them is based on the published literature. They're all based on highly replicable, very well established cognitive phenomenon that we know you will be able to measure on your own. And we've been able to show that people are really good at doing these types of games. So you will have a screen like this. It gives you instructions. You'll push orange buttons. So for instance, this says you yawn for your dog. And the question is, does your dog yawn back? And that is ridiculous, I agree. But it is an incredibly powerful measure of emotional contagion. There was just a study published last week showing that dogs are more likely to contagiously yawn towards individuals they have a strong relationship with than people that they don't know as well. And we know that kids develop emotional contagion as they begin to think about the thoughts of others, and those who don't struggle to understand others' feelings. So, does your dog contagiously yawn? Is your dog, relative to other dogs, one that shows a lot of emotional contagion? Is your breed one that shows a lot of emotional contagion? I don't know, but you can find out. So here's what you'll get in your report. This is sort of a summary. On each of the 5 dimensions that we're going to help you measure, you'll find out, okay, my dog is a little bit more individualistic when it comes to empathy, so probably didn't yawn when you yawned, doesn't make a lot of eye contact with you. Is really good at using gestural communication here, relies on, that's why they're more collaborative. Maybe not so cunning, and their memory is a little bit average, and they're doing pretty well in the inferential reasoning games. So you'll get a profile like this for each dog you test, and then there's a lot of details about what that all means, and one of the fun things is you will end up being assigned one of these cognitive profiles. There's a badge for each one, so your dog will end up as an ace, an Einstein, a charmer, a socialite. My dog is a socialite, thank you very much. A proto-dog, a stargazer, etc. And basically what these different 9 cognitive profiles represent is this is real, this is based on statistical analysis, there's just a cute face put on it. Is that it basically measures on 2 dimensions, is your dog an independent problem solver, and is your dog a dog that is solving, or what are your dog's social strategies it relies on? So an Einstein, for instance, might not be the most socially inclined dog, but amazing at solving problems on its own. No shame, just different than other dogs. So these profiles will really help us explore and explain what dogs are doing. So here's my question. Is it that your breed ends up as one of these cognitive profiles, or is it that they're all over the place? Or is it that some breeds are distributed across all of these profiles and some breeds are really narrowly in 1 or 2 of these profiles? I have no idea. But we can find out, because you can all be citizen scientists. You can go to CanineCognition.com, you can play these games, you can encourage your breed groups to play them. And this is your moment to brag about your breed and to have us help you illustrate why you're so in love with the breed that you're in love with. Because of the cognitive profile your dogs have, and that's what makes them so wonderful. I think there was, a while ago, a list of breeds and which one was the most or least intelligent. If you're at the top of the list, you're going to be mad at what I'm about to say, but I can tell you, take that thing and throw it away. It's not based on anything in the published scientific literature. It's based on, a survey of people's perceptions of how obedient their dogs are. And so, that's interesting, but I just tried to help you understand that cognition is about the internal processes going on in the minds of your dog, and that there's really no good or bad answer to this. It's just a question of what is your dog? And so that's what we need to do if we're going to help our dogs. So we've been trying to use, Cognition is also working with Pet Finder, and CCI. CCI, we're working the same way we do at Duke, but the Pet Finder project is really fun because you can imagine there are dogs at shelters that are physically not particularly attractive, and they're not going to be the dog that gets a lot of attention, but inside, they're wonderful. And so, you know, just like Antique Roadshows, where my mother watches it, I'm sitting there, that piece of crap that just came across the television cannot be worth $2.50. And then the guy prays her and he's telling about how George Washington saw that one time and, you know, Benjamin Franklin touched it or whatever. That's gotta be worth millions of dollars. And it's the exact same thing. Those objects become valuable because of the story and because of, obviously, what's inside them. And so that's exactly the same thing CognineCognition can help with shelter dogs, is we can tell the story of the dog that people might not be attracted to, but actually is an incredibly attractive dog inside. And we've already seen some success. So go find the genius in your dog, in your breeds, and I hope we have time for questions. Thanks to all my lab, a lot of people make this possible.
We have time for about 1 or 2 quick questions. Brian is going to be here through the break, and then he's got another engagement he needs to head off to. So I'm sorry we're running out of time, but definitely try to talk to him at the break. Yes, go ahead.
Would it be appropriate to use some of these CognineCognition tests to help you place puppies in the appropriate home?
Yeah.
Well, so people have asked me, okay, so once you figure out what the cognitive profile is, what can you do with it? And so I'm a scientist, so I will answer. My CEO is not here, so I can answer you as a scientist.